This video is going to address the issue of conditional probabilities, and we'll use the conditional probabilities to define the notion of mathematical independence between two variables. We'll begin with the same information we have here, but I'm going to clear these contents and clear this 0, and I'm going to put the conditional probabilities in the cells in the contingency table at the bottom. The conditional probabilities are found by taking the joint probabilities and by column and dividing those by the column marginal probability. So to begin, we will say that this conditional probability is equal to 0.2055 divided by the marginal probability for that column. Since we always want to operate in row 13, we will fix this with $13 and drag it all the way down. And since we're dividing here 3623 by 3623, we have a 1 in this marginal position. Now I'm going to copy this all the way across to grand total. These internal cells represent the conditional probabilities. Their interpretation is the following. Given that a person came during the first shift, there is approximately a 57% probability that they will come for an emergency and a 43% probability that they will come for something else. Given that, for example, they came in the third shift, there's about a 75% probability that they came for an emergency and about a 25% probability that they came for something else. Overall, there's about a 65% probability that people came for an emergency and about a 35% probability that they came for something other than an emergency. Now we can address the issue of mathematical independence. If these values in each of these three columns, the conditional probabilities, are equal to the column marginal probabilities, then shift and emergency status are mathematically independent of one another. It's easy enough to see that 0.56 is not the same as 0.64, 0.74 is not the same as 0.64, and even though 0.65 is close to 0.64, these two values indicate that shift and emergency status are not independent of one another. For them to be independent of one another, all of these column values, all of these marginal probabilities would have to be exactly the same as these probabilities. All of these conditional probabilities would have to be exactly the same as these marginal probabilities.